Iodo, at your service. In today's video, I'll be exploring some different ways to harden leather, and I'll be trying some experiments, and then I'll hopefully be able to come to a conclusion about what the best method is for making armour and hardened leather items. In context. A while ago, I watched Kramer's video of how he made his Witcher armour. It's an awesome video, by the way. You should probably check it out if you haven't watched it already. Spoiler alert on his video, by the way. For his hardening process, he used an oven to heat the armour after he'd made it. His armour did end up burnt. When I watched that, I immediately put a comment on his channel saying that you can harden leather by dipping it into or pouring boiling water onto it to avoid it getting burned. Personally, that's what I've always done for hardening leather, but I've never hardened anything as big as armour before because I've never tried to make armour, so I can't claim to be experienced, which is why his reply was interesting, because he said that he ran some tests with boiling water and that he found that there was a lot more shrinkage using boiling water than there was in the oven. And of course then he says that this would be a great thing to showcase on my channel. So, challenge accepted. I'm making a video about hardening leather and I'm going to try some different ideas and some different methods. So I've got a massive amount of nice thick armour weight leather. These pieces are from a different tanner than these pieces, so I'll try to use all the leather from the same tanner so that it's consistent. So let's do some science. So the first thing I think I'm going to do is I'm just going to cut a simple piece of leather, like, I don't know, about 4 or 5 inches square or something, and I'm going to measure exactly how big it is and I'm going to write it down, and then I'm going to harden it flat in boiling water and we'll see how much it shrinks. This will fit in a pan. A full piece like torso armour wouldn't fit in a pan, so maybe that's why you don't see hardened leather armour in history. Because what you do see in history is the lamella armour, which I'll put a photo of up on the screen, and that's made out of lots of little pieces that are sewn together. Now, say in history, hardening with hot air is going to be a lot harder than it is in modern day to achieve. So I was thinking that if they were going to do it, they would probably do it with boiling water. So that might be why you see the lamella armour, which is made out of lots of pieces in leather, but you don't see the full torso hardened leather armour. Okay, so I'm going to be using a pan to boil the water. You can use a kettle or basically anything else. Because I can't have the tripod there and over the pan at the same time, I'll talk you through what I'm going to do before I do it, and that should probably work better. In terms of equipment, I haven't actually got much. What I have got is I've got the hob, which is a heat-resistant flat surface, which is important. I've also got a pair of gloves. Now these aren't waterproof, but they are heat resistant, so although I can't dip my hands in the water wearing them, I can handle the hot leather after it's been got out wearing them. So in order to dip the leather into the water, I've got a little pair of pliers so that I don't burn my fingers. What I would normally do is I would wait for the water to boil, and then I would turn off the heat and let it just stop boiling, and at that point I'd dip the leather in. So if you want to boil the water in a kettle and just pour it in a bowl, you can do that, but it might cool the water down a bit, the fact that it's been poured into a cold bowl. What I would then do is I would dip the leather in the water and I would hold it underneath the water until the bubbles have come out. That means that the water's got to the middle of the leather and then I would get it out. So it's not going to be in the water for very long, and you'll see what I mean when I do it. Okay, so that's come to the boil now, which means if I turn it off, now if I just drop that in, you see how it's bubbling because the air's all getting out. If I wait for it to stop bubbling, there we go, that will do it. So for now it's still flexible, and I'll flatten that out and let it cool down. Okay, so it's cool enough to touch. It hasn't hardened up yet, it's still a bit flexible, so I have to make sure that it doesn't curl up because it has a tendency to do that. Now it's time for experiment 2. Experiment 2 is going to be hardening with a hot air gun because I thought I should try that. But before we get on to experiment 2, I'm going to quickly mention this one thing that I discovered on experiment 1. The leather that I've used before for hardening has come from a different tannery than this leather. This behaved completely differently hardening to the other tannery, which suggests that some tannery companies might be better for hardening leather than others, even though it's all veg tanning. So I'm guessing that there must be differences in the process, because when I harden other projects that I've done, it has actually become hard as it's cooled down before it's dry, and it's become hard pretty much within about 10 minutes of having heated it up. And this didn't. This stayed bendy for quite a number of hours, so I actually thought that it hadn't worked. And I thought that was quite strange, but it must be something to do with the tanning process, because although it didn't harden up as it dried, it took at least 3 or 4 hours to actually become hard. But it has become hard, so it has worked. Right, so back to the second test. I have never tried to harden leather with a heat gun before, so I don't know what I'm doing. So forgive me for that. I don't even know if it'll work. I wasn't entirely sure how to actually apply the heat to this, because if I just put it on a piece of metal, then the piece of metal will get hot, and it'll get hotter than the air is hot, so it'll probably harden unevenly or curl up or something. So what I've actually done is I've got a chemical clamp stand, and I was going to suspend it on string or wire or something, but that would mean punching holes. So because it's a test, I'm just going to clamp it in a chemical clamp stand and put hot air on it. Now the next challenge is going to be, I will have no idea how hot it actually is. So what I thought is, if I use this, which is an infrared thermometer, I can actually measure the temperature of the leather, and if I heat it to 100 degrees ish, then I'll be able to know that it's essentially should be the same as the boil hardened leather. We'll see. So the first thing I'm going to do is I'm going to make it wet, because that seems like the most sensible thing to do, because otherwise I think it will just catch fire. Now this is cold water, unlike last time, so it's like making it wet if I was going to do tooling or something. This is just a completely ordinary heat gun from a hardware store. I think it cost me $9.99 or something. Let's try this. Okay, that's interesting. Firstly, that was an awful lot harder to do than I expected it to be. Secondly, the cheap hardware store hot air gun seems to stop at 75 degrees on the thermometer. I can't get this any hotter than 75 degrees because I carry on heating it and it just stays at 75 degrees. So I guess that that's the temperature range of this thing. The other thing that's happened, which I actually didn't expect, or at least I didn't think of, is the metal on here has actually heated up hotter than the leather has heated up, so it has burnt the shape of the claw on my clamp stand into the leather. I don't know if it's going to harden, and it hasn't shrunk, so it probably won't harden. We will see. It's the next day. The piece of leather that I attempted to harden wet with the heat gun yesterday is dry. I did do some maths. So there is a number called the latent heat of vaporization for any liquid, which is basically what determines how much energy it takes to turn the liquid into a gas, which is what's happening when I'm using the heat gun to heat this up. That number is enormous for water, So what I'm doing when I'm heating the wet leather up with the heat gun is trying to overcome that number to evaporate the water, and every time water evaporates it takes away heat energy and doesn't warm up the leather. Although the heat gun is quite hot, it isn't good enough to reach a temperature above the equilibrium of 70 degrees, and that's a 70 degree surface temperature because the wet leather in the middle isn't going to get hot at all. So that isn't going to work if the leather's wet, unfortunately. Now it would work in an oven, because in an oven you've got a trapped box of hot air, so the energy transfer into the leather would be much faster. But in open space just on the clamp it's not going to work really. The only way to harden this through, like the boil hardening did, using a heat gun, is probably going to be to heat it dry, and if I can do that without scorching it then it might work. I don't know, I've never tried that. But before I do any more experiments with the heat gun, let's see how much it did actually harden. So I have got a gadget here. This is called a durometer. This is a device for measuring the hardness of a surface, and the way it works is there's a little sprung cylinder underneath which presses into the surface, and you put it down so that the surface is flat with the top of the plate, and that then measures the actual hardness of the surface in a measurement called shore hardness. I was going to use it to measure the difference between different hardening techniques and see which is better, but for now I'm just going to see how much this actually hardened here, because the surface feels a lot harder than it was before, even though it's still about as flexible as the original leather. Let's get some numbers. My hardening attempt from yesterday, which was done wet with the heat gun, is between 85 and 89 shore. And the original leather, just in case it's got hard spots and soft spots or something, I'll take it from just where I cut the pieces that I was experimenting with yesterday. That's like 83. So a difference from 83 to 85, well, 85 to 89, that's basically negligible. So what I did yesterday has done absolutely nothing at all to the leather. And it hasn't shrunk even slightly, which would imply that nothing's happened to it. So yesterday's attempt was a failure. Let's try doing it dry. So that has got up to a measured temperature of about 93, so nearly 100. That is the surface temperature of the leather. I can't speak for the inside temperature of the leather because I've got no way to measure that. And I don't know how well this will work, so I'll wait for it to cool down and we'll see. When I started making this video, I thought that I 100% understood the process of hardening leather. But now I've done some experiments and some maths and some thinking and some research, I don't understand it at all anymore. Science does that. I have left this piece to stand for it's completely cold, maybe been about an hour or so. It should have reached its maximum hardness after my attempt to dry harden the leather. Just remember, this was heated up to basically 100 degrees, so this, if dry hardening worked, should be as hard as this piece. Honestly, it hasn't worked at all, which leads me to believe that you can't harden leather dry, it actually has to be wet or it won't work, which is interesting. I don't know why that is though. So has it worked even a little bit? Let's find out. That is averaging now at 93. Before I attempted to dry harden it, it was averaging at 87, so it's made it go up in hardness a tiny little bit. Now the boil hardened leather, which has essentially been heated to the same temperature as this, but for less time, while wet, is actually become so hard that I can't bend it at all, and it's basically wood. That's how hard it is. Whereas this still feels basically the same as it did to start with. If the surface has got a little bit harder, then that's what the meter's picking up. Now my aim for this video was actually to test whether air hardening or water hardening was a better process. So in order to achieve my aim for this video, I think I might just have to make this wet again and put it in the oven to get it nice and hard, so I can compare the air hardened leather with the water hardened leather. So it's another day again. I've got to honestly say, this is the longest amount of time it's ever taken me to film a single video, because most of the video filming process has been waiting for stuff to dry. So my next task, because the air hardening didn't work, is to oven harden a piece of leather, because I want to test air hardening as a process and using the heat gun wasn't enough, so I'm going to bake it in the oven. I was initially just going to use this same piece, but then I thought that's had loads of random things done to it already, so I'm going to start again with a new piece. So now I get the same oven hardening process that Kramer had, which is I've got to work out how to oven harden it without burning it. Now I gave this some thought. There's various different theories I've had, like tying it to string and suspending it from a piece of wire inside the oven or something like that. But then I thought, well, why did it actually burn? Because inside an oven, when the air inside the oven is the source of the heat, then everything inside that oven should reach the same temperature eventually. But certain things are going to heat up faster than others. So I was thinking about why that is. There is actually a number called the thermal conductivity coefficient for every material, which shows how fast heat can conduct through that material. So something with a really, really high thermal conductivity coefficient, like copper or aluminium, which are typically materials that are used as heat conductors inside radiators and heat sinks, will get hot really quickly because it will absorb a lot of heat from its surroundings faster than anything else. Whereas things like leather have a very low thermal conductivity coefficient, so they'll heat up much slower. Which essentially means that with mild steel, which is what baking trays are made out of, because that number is much higher, it will heat up faster, and the leather that's in contact with that surface will be getting hotter faster, and it will essentially end up being overdone where it's been in contact with the surface, because it will reach its temperature quicker than the rest of the leather. So what I then ended up thinking was, what if I could find a material which can survive the heats within an oven, which has a lower thermal conductivity coefficient than leather? Like, I don't know, maybe Teflon or silicone rubber. If I use something like that, then in theory it shouldn't burn. So if I use silicone rubber, I should be fine. So I've got a silicone rubber baking tin thing. So by the law of maths, if I use this to heat my leather on, the leather won't burn. We'll see how right I am in a minute. The first thing I've got to do is I can't heat it dry, because we already proved that that doesn't work. It gets up to temperature, sits there for ages and then never hardens. So I've got to make it wet back in the cold water. The bubbles have stopped coming out now, so it's fully saturated. Fully saturated is what I want, but really it's too wet. So what I'm now going to have to do is put it in the boiler cupboard, wait for it to dry off a bit for several hours. Yep, more waiting. And then I'll be able to put it in the oven on the tray and we'll see what happens. I will be putting it in the oven at 100 degrees centigrade, because that's as close as my oven will go to the recommended 200 degrees Fahrenheit for hardening leather. 200 degrees Fahrenheit is 93 centigrade, I think. So it's quite close, for about 20 minutes, and we'll see what happens. this has now been in the oven for 20 minutes at 100 degrees. Okay, so the leather itself still feels damp, although it feels a lot hotter than I could get it with the heat gun. And it's measuring now 85 degrees, but it's been out the oven long enough for me to move the tripod. So it probably was at 100 degrees before. The baking tray itself, the silicone, is also measuring pretty much exactly the same. So the silicone is heated up at the same rate the leather has. As a result, the bottom of the leather isn't burnt. However, I can actually see darker lines where the oven grill shelf thing were underneath the silicone. So I'm presuming that that again is because heat has conducted through from the metal, so it has actually heated it a little bit more. But it isn't burnt. So I'm hoping that that will harden. And if it doesn't, well, all my experiments have failed. We will see. So it's been a few more hours. This is my oven hardening attempt. It might be a bit stiffer, but it hasn't actually shown any signs of hardening at all. I think that might actually be because it was too wet when I put it in the oven. So my mistake, I was impatient. So I think now it's dried out a bit more. It is still damp. I'll put it back in the oven for another 20 minutes and see if it hardens again, because I'm determined to make this work. Other people make it work with just 20 minutes, so I don't know. Maybe the silicone thing cools it down a bit or something. I've just put this piece back in the oven and I've put it in for 35 minutes at 120 degrees centigrade. So if this is going to harden, it will be hard when it cools down. I was giving the foil hardening thing a bit of thought. This is a very messy piece of leather. It's a bit curled at the edges and it doesn't look very, I suppose, well finished. But I was wondering if it would actually be possible to do a bigger piece. Now, this is my original size. That's how much it shrunk. That's quite a lot. Over a large piece, that is going to be a lot to cause an actual problem with sizes, because your boiled piece will end up being a lot smaller than your original pattern. And the other thing is, when it comes out of the boiling water, it's still pliable, so you'd have essentially that amount of time to wet form it, because you wouldn't be able to wet form it first, because the shrinking and curling up and whatever else is going to ruin any pre-existing wet forming. So you wouldn't be able to do a complicated project where the wet forming would take you ages. But it made me wonder if possibly a simpler project which was larger would actually be possible. So I thought I would do a trial. But first, I did some maths. I'm doing a lot of maths in this video. So I measured the length of the side from there to there and from there to there. And I also measured it from there to there and there to there. The reason for that is because the shrinkage isn't completely even. And then I used the original piece to work out how much it had shrunk. So don't use these numbers if you're doing your own project, do your own sample, because different tannery leathers behave differently and may shrink different amounts. But for this leather anyway, this shrunk to 93% of its original area. So what I then did was I made the pattern. That's a reasonable size for an armoured plate. If you were making more complicated armour, you wouldn't be able to do it sewn together, you'd have to sew it together afterwards, so you'd have to work out what all the sizes were going to be and have it made in a separate panel design or something somehow. So I did that, and then I thought, well, this is my target size. I'm going to try and boil harden something so that it ends up this size and slightly curved afterwards. So then I made a pattern using a mathematical formula to work out exactly what size it needs to be. So the white piece of paper is how big the leather needs to be, so that when it shrinks to 93% of its original size, it should end up the same size as the piece of corrugated cardboard. And now I have cut a piece of leather to that size. So I'll try and boil harden it. So this is my piece of leather. Obviously I haven't got a pan big enough, which is where it's going to get difficult to boil this. So what I've got is I've got the oven set to 150 degrees and I've got a big baking tray in the oven which is deep enough to fill with water. When the metal has warmed up, I'll get it out, put it on a heat-proof surface, fill it with boiling water and then put this in it. The boiling water will come from the kettle, and in theory that should allow me to boil harden this piece. And I'm hoping it will shrink down to this piece. Now, in order to do it, if you remember last time when I did the little sample, I had quite a lot of difficulty catching it out of the pan with the pliers. So what I've done is I've gone to the hardware store and I've got a pair of gloves which are thermally insulating and 100% waterproof. So although these aren't rated for this use, I should be able to just dip my fingers in the boiling water and not burn myself and fish this out, so it will make things a lot easier. And it will also mean I can touch it in order to wet form it with gloves that fit me. So hopefully that will work a little bit better. That is, if the gloves don't melt. I should probably check they don't melt before I try this. Most things haven't worked so far, so hopefully this one will. What I've done is I've actually managed to make it a decent sort of bowl shape, like a proper metal breastplate would be, and it's not half bad. It's better than I thought it would work out, actually, because there's quite a good shape on that. So although it's a very simple piece, that's essentially why I've been able to do that. The edges are still curled up, there's nothing I can do about that. So the way that I've worked out of making it kind of stay in the right size is just to leave it on a screwed up towel. It's not very scientific, but it ought to work. It's only wet formed by eye anyway, so there's no templates or plan going on here. So that's that. The piece I oven hardened has actually set. This has actually gone hard, so I'm quite pleased with that. It's got a little bit of a dimple in the middle. I don't know why that's happened, but it's just the shape it's ended up, so I don't know. But it's not burnt, so the silicone works. I'm wondering if perhaps my oven is colder than it says it is, because when I got it out, when it was set on 100 degrees, I measured the temperature of the metal trays inside the oven and the oven sides with my IR thermometer, and it actually came in at 90 degrees, so maybe it just wasn't hot enough. So when I put it in at 120 degrees, it's worked, but I might have done it a bit too long, which is why it's warped the shape. So that might be why that didn't work. So the notes on the process. Firstly, These gloves I shouldn't recommend because they're not rated for what I use them for, but I will recommend because if you're planning to do this, these are amazing. Now, the latex coating on the back that makes them waterproof only goes up to here, so you can only dip like your fingers into the boiling water. But because they are thermally insulated on the inside, so they're fluffy, they're designed to keep your hands warm rather than protect your hands from getting warm, but that stops it from burning through. And it enabled me to actually manipulate the leather under the water, which I wouldn't have been able to make that if I hadn't been able to do. And it also enabled me to start to form it while it was still too hot to touch. So I'll see how well all the stuff worked, and I'll be back to you when I've tidied up the enormous mess and waited for stuff to dry again. I'm back with you about 3 hours later or so. It has not been long enough for this piece to harden fully or to dry fully, but it is hardening up quite nicely and I think it will be great. But it has been long enough for the oven hardened piece to fully dry and harden. And that means I can do my conclusion. So firstly, what have I learned? The answer is quite a bit more than I thought I would, because it turns out there's a lot more to hardening leather than I ever imagined. I think I understand it better now then. What else have I learned? Well, our oven isn't as hot as it says it is. Leather by different tanners behaves totally differently, even when it's all veg tanned. If you plan to boil harden leather, use gloves like this, it makes your life a lot easier. I'll put a link to these in the description. If you plan to oven harden leather and you want to do it without burning it, get yourself one of these. And talking about this, the first time I used it the traditional way up and the leather was inside. That means there's only the thickness of the silicone between the leather and the grill that's underneath, and I did see the lines come through on the leather. Now the second time I used this, I actually put it upside down. I know that that wouldn't work for something that's too heavy that would compress it, but it prevented the lines from showing through because then it's just airspace that's underneath. Using a hot gun to harden leather doesn't work, and leather doesn't harden if it's completely dry. So that just about wraps up all of the fact related things that I learned doing this. Now it's time for the numbers. So because my oven hardened piece of leather is fully dry and set, I have been able to measure that as well. So like I did before where I measured the average shrinkage over the surface, I have done exactly the same with this, and I've got a number for this as well. So, shrinkage comparison. The boil hardened leather, as I said before, shrank to 93% of its original size. That is 7% shrinkage. The oven hardened piece of leather only shrank to 98% of its original size. So that is the much smaller value of 2% shrinkage. You can see the difference pretty clearly here. Now to see if I could make something to a target size which was larger using boil hardening, I made my other piece. So I used that 93% to measure this. This was my target size. If I overlay them for the camera, I'll put up a picture on the screen so you can see it better. You will see that it is right from the bottom edge to the bottom edge, and it is right from the bottom edge to this corner. And for some reason it hasn't shrunk at all from that bottom edge to that corner. So I have learned that leather doesn't shrink evenly. Why that is, I don't know, but what it does mean is that if you're planning to make something oversized so it shrinks down to a target size, it isn't going to be that precise. Now if I was fussy and this was for a workpiece, I could actually cut this triangle off the bottom, which would end up with it being the right size. But that would also mean that the edges would all look different, whereas instead of having this boil hardened slightly curved edge all the way round, the bottom edge would be straight and neat. I would probably have to use a saw because it's hardened. So what about finished hardness? Well, I've got the jawrometer, which means I can actually compare directly the boil hardened leather and the oven hardened leather to see which one is actually harder. Which is very interesting because just feeling them, they feel exactly the same. Possibly the oven hardened one is a bit more flexible, but they basically feel the same. So when I measured it, I took 5 readings from the 4 corners and 1 in the middle on both pieces, there, there, there and there and there, and I made an average. So they've both been measured using an average in the same way. The oven hardened leather came in at 90.4 sure on the hardness scale. The boil hardened leather came in at 95.2 sure on the hardness scale. So the boil hardened leather is quite a bit harder than the oven hardened leather, even though they feel basically the same, which is interesting. So what can we take from this? I hoped to be able to say which hardening method was better. I don't know if I can or not yet, but what I can say about oven hardening is the following. It keeps its shape better, it doesn't shrink much, it doesn't rely on having a big enough water container to be able to boil water in. You have as much time as you want to wet form your project because it isn't going to suddenly go stiff like hardening using boiling water will. It's easier if you know how hot your oven is and how long to do it for. So if you're planning a oven hardening project, do cut a test sample and try it out, just so that you know what you're doing before you're doing your actual workpiece, so that you can do it nice and smoothly. But boil hardened leather is actually harder than oven hardened leather. Now, I'm not biased in any way, I was completely interested by this experiment. I probably overcooked my oven hardened leather because I put it in for half an hour because I was having trouble making it hardened, and that's why the edges went curly. So if anything, this piece is probably harder than average oven hardened leather when you haven't warped it. So because of all that, I honestly cannot say which is better. There are advantages and disadvantages to both, but what I will say is that boil hardened leather cannot be done unless your project is simple and you have a big enough pan or tray or something. So I'll end the video on this thought. So we know that the boil hardened leather shrank 5% more than the oven hardened leather. Does that not make it more dense? And would a more dense leather not make for more effective armour? I don't know, so what do you think? Let me know in the comments. I hope you enjoyed this and I hope it was useful. Thank you so much for watching, and I'll see you in the next video. But another thing worth noting is, because I want this to still be flexible so that I can get my hand in it, this isn't hardened to 100 degrees. If you harden leather to different temperatures, the hotter the water, the harder the leather will go. So this would probably harden to about 50 or 60 degrees, which leaves it being able to be bent but still pretty solid. So I'm going to dip it in the water until bubbles stop coming out. The water is cold this time. I don't even know if you can see the water on the camera. Can you? Apparently you can't see the water on the camera. I'll move it over here. I'm hoping this time it actually will go. You can't hear me because of the extract fan.